If large numbers of people start to die in any of those countries, their governments will act independently in their own interests. We should be talking about that.
We are not implementing climate policies fast enough to stop emissions, and we're not investing in adaptation enough. Adaptation needs are anywhere from 1 to 10 trillion per year, and we're maybe investing 100 billion. By the end of this century, the UN is telling us 1 million species at risk of extinction. 1 million. Engineering. Can we use technology and human ingenuity to repair the climate and undo the past 3 or 4 centuries of mass damage to the atmosphere?
One idea we've heard a lot about is carbon capture.
Both direct air capture and carbon capture and storage, the consensus was not till at least 2045 and possibly 2055 or 2060. So that does imply that these options could play a huge role in 20 or 30 years, but if we're looking for like a near term, within 5 years deployment, they're not even close to ready.
What does work now?
So solar panels and wind power are the biggest 2 things you need to do for electricity. And reforestation and better land use management. Those 4 things get you some huge magnitude of emissions reductions that's like greater than 20 or 30 other things combined.
Is there any other engineered solution that could help?
Solar radiation management, which is basically a fancy term for how do we reflect sunlight so that we can lower temperature. Put a shade over parts of the earth to like keep the sunlight from warming coral reefs and things like that.
By spraying chemical particles in the stratosphere, right?
It's usually sulfur. Keep in mind as well that stratospheric aerosol injection will just be emitting a few tons, potentially, of things like sulfur, or a coal-fired power plant emits millions of tons a year. So it sounds bad in an absolute sense. Oh, these planes are spraying particulates. But in a grand sense, it's going to be less than like 0.001% of what we're already putting into the atmosphere anyway. So the additional increase in air pollution is negligible.
And blown wherever the wind takes it.
They would create asymmetries in protection, as in it's not even protection. It depends on how the aerosols disperse. And I think these sorts of dynamics are why we need more modeling, more science, more research.
We must establish water bodies when it rains. Then we must put plants in to stop that water evaporating, leaching, or whatever else. Life starts by water bodies, and then the plants gradually spread away. That means that as they spread away, they actually manage the water. It's fundamental to everything that happens in the environment.
Is there enough water over in Western Australia?
Oh, there's some huge river systems up there, and they get to dump in the wet season.
But it all just flows out to sea?
That's what we've got to do, slow the flow.
I am using only the indigenous knowledge system and traditional design and engineering.
Could we do something similar in the heat engine of Australia to make it greener and cooler? Right. And we want to create wetlands to build up carbon and nutrients so plants will grow.
That creation is possible in your country if you like.
The heat engine of Australia is larger than Rajasthan and Gujarat combined and has similar climate and rainfall, about the same distance from the equator.
Those 2 states have a combined population of roughly 150 million people. That's 100 times greater than all of Western Australia.
Rajasthan has a long and successful history of water management we can either learn from or we can ignore.
What if we followed the waterman's lead? The climate and wet season rainfall in WA is remarkably similar to Rajasthan. What if we built johads to stop the rainwater from pouring into the ocean? What about the cost?
It'll cost $50 million a year for 10 years, $500 million.
Well, that's a lot cheaper than the $2 billion that they estimated to raise the wall.